For this assignment, you are going to be typing into these white boxes and inserting an image into the boxes that need an image. And we're going to be using this site here in order to get what we're doing. So as I look onto this first slide that says this electrical potential in a uniform field, I just wanted you to have what the equation is for an electrical potential in a uniform field. You can watch this video to actually visualize it. You can see a little bit more on this. I just wanted you to have the electrical field. In this, I want you to show me the electrical potential around a negative charge. So I tried to give you an image, that way you have an example of what an image is supposed to look like. But in this text, what you got to do is you got to delete this text. When you delete this text, this is where you're going to type in your explanation of where you're going to try to say how this electrical potential depends on distance around this negative charge. So give your explanation, try to talk through it. Down here, this is where you're now going to use a positive charge. So I want you to insert an image for a 1 positive charge from that one site, similar to that 1 negative charge, but now it's with a positive charge. And then you're going to plot 3 equipotential lines using that site. And so you're going to do that there, and then give an explanation about that potential and how it depends on distance. I'm going to show you in a moment what I mean about this, but I'm just going to continue so that we know what we're doing here. This one, we're doing 1 positive charge, 1 negative charge, 3 equipotential lines. Give that explanation of that, of how this potential depends on the distance from these charges. So you got to say what that force is, how the magnitude is, how is this potential changing over that distance. And then I want it in a uniform field. So I tried to show you a setup of how to create a uniform field. That's where we create a bunch of positives on one side, negatives on the other side. And I want you to, once again, answer this question of how this electrical potential depends on distance. Down to here where I'm giving you work is energy. I want you to watch this video. And then underneath it says, did you watch the video? You got to tell me that, yes, I watched it. There's nothing else I'm checking on that. I want you to actually watch this video on work and energy. I want you to just watch that a little bit. Just watch it. There's nothing you got to do. I just want you to look over it. As I go back to here, I want to show you a little bit more about what I mean about doing this simulation and setting up. So we're going to place 1 positive charge and 3 equipotential lines around that charge. So I'm going to place 1 positive charge, and you can leave the electrical field clicked on. You can click it off. I like to have it on because it shows me the electrical field. It's really bright close to the positive charge, so that says the intensity, and it's really faded away, so that means it's weaker away, but all the arrows are all pointing away from that electrical field. If I move the charge, it shows that. So then I can bring out this volt meter right here, and it's going to show my equipotential. And I can draw the 3 lines. 1, this is at a value of 7 volts. I can go at a distance farther away and distance farther away, and now I have my 3 equipotential lines. If I don't like this one because now it's off the screen and I like to have a full circle going around it, now I have drawn up the 3 equipotential lines. I get my screenshot. I insert my screenshot into here, so that way I have my understanding of my image on here as well. If you don't know how to do a screenshot, I have embedded in here how to take a screenshot with your Chromebook. Then I want you to also get 1 positive charge, get 1 negative charge, and create then a uniform field while you're all trying to address how does this electrical potential depend on distance.